incandescent storms big enough to swallow the Earth. Bolts of lightning thousands of miles long. Raging infernos of toxic gas. Inconceivable violence and terrifying extremes. These are the planets from hell. Our sun is only one of 200 billion stars that make up our galaxy, the Milky Way. Like our sun, each star could be orbited by its own system of planets. Today, astronomers are piecing together incredible new evidence in the search for distant worlds. Theirs is the ultimate scientific quest. They are the planet hunters.
There's an absolute explosion going on right now. This is by far the most amazing time in astronomy that could ever be imagined.
These astronomers have discovered planets of frightening proportions that would dwarf any in our own solar system.
When I heard of the discovery of the first planet outside of our solar system, my first reaction was amazement.
Their research has opened a whole new chapter in the study of astronomy.
Every once in a while, a field in science will crack open and you get a peek at something that's never been seen before.
Theirs is a remarkable story of discovery, a scientific revolution that has changed our view of who and what we are. Now a race is on to find what planets lie beyond our solar system. Will they all be planets from hell, or could any of them be like Earth? Hawaii, where astronomers head to gain an unparalleled view of the heavens. On top of the 14,000-foot-high summit of Mauna Kea, high above the obscuring clouds, stand the two mighty Keck telescopes.
Well, there she goes. The two Kecks.
Home sweet home.
It's great to be here.
Inside these enormous twin domes are the biggest and most powerful telescopes in the world. So powerful, they could see a candle flame on the moon. Each of the two telescopes has a vast mirror over 30 feet across, essential for capturing the faintest starlight. This is the hunting ground of the world's most successful planet hunting team. And king of the planet hunters is Jeff Marcy.
I think the most important thing we're learning here in our search for planets around other stars is we're learning about how our solar system fits in to the grand cosmic scheme of planetary systems. Is our solar system unique, special, or is it some common run-of-the-mill type of planetary system?
Marcy and fellow astronomer Paul Butler use the Keck telescopes to hunt for planets billions of miles from Earth. But even with the power of the world's most advanced technology, a planet circling a distant star is too small and too faint to be seen directly. Instead, they have perfected an ingenious technique to find these invisible worlds.
planets in principle is actually easy. We watch the star itself and look for the planet, which we actually can't see at all. It's blocked out by the glare of the star. So we watch the star itself to see if it wobbles in space due to the gravitational pull on the star by the planet. So we're simply watching to see if stars are stationary or wobbling.
When a planet orbits a star, its gravitational force will pull the star off center, making it wobble from side to side. The largest planet in our solar system is Jupiter. It's so vast it could swallow 1,300 Earths. 500 million miles out from the Sun. It takes 12 years to complete each orbit. As it travels round, Jupiter pulls our Sun off center by as much as 500,000 miles. The planet hunters believed that if they could find another star performing the same cosmic dance as the Sun, then it too would be orbited by a Jupiter-sized planet. Marcy and Butler began their search in 1987. They chose 100 of our closest stars, many visible in the night sky in familiar constellations. The two astronomers were convinced they'd soon find a wobbling star and detect their first planet.
We honestly thought in 1987 we were going to go to the telescope and boom, that we were pretty quickly going to figure out how to find planets, that we were very quickly going to do as well as anybody in the world. And in fact, we found out the problem was so much harder than that.
For year after year, they could find no sign of the wobble they had expected. They began to doubt if there were any planets out there at all.
It was an extraordinarily trying and depressing time. Day after day, coming into the office, leaving at the end of the day, realizing that we did not yet have the ability to detect planets. I was worried that we were wasting telescope time and, frankly, wasting our whole lives.
Then, in 1995, came a breakthrough. But not from Marcy and Butler. Half a world away, a rival Swiss team of planet hunters was working in southern France. One of them was Didier Queloz. He was still a student studying for his PhD. Like the Americans, Queloz was sure that planets must exist throughout the galaxy.
I was pretty much convinced that there are planets there. Yes, you know, in science you never really start something if you don't think that you will find something. We're not crazy. We were pretty much convinced that there were planets. That's why we decided to look for them.
At the telescope in Provence, Queloz searched for wobbles in stars that had been overlooked by other astronomers. 300 trillion miles from Earth, in the constellation of Pegasus, is one of the stars he was observing. Visible to the naked eye is 51 Pegasi, called 51 Peg for short. Even traveling at 186,000 miles per second, the light from this star has taken nearly 50 years to reach Earth. After just a few weeks of measurements, Queloz found the first hint that 51 Peg was wobbling. But the way the star was moving was very different from anything anyone had expected.
I was very puzzled, and I really thought, oh my god, something is very wrong with the instrument.
The rapid movement that Queloz recorded suggested that something was orbiting 51 Peg inconceivably fast. The astronomers had all been looking for a planet like our own Jupiter that would take many years to orbit its star. Here was something entirely different. The planet that was orbiting 51 Peg was almost the size of our own Jupiter, but the big surprise was the length of its orbit. Rather than orbiting every 12 years, it was racing round in less than a week. After double-checking his wobble data, Kello knew there could be no doubt.
The only phenomena or the only interpretation we are left with is a planet. There is no other way to explain what we're seeing except that being due to a planet. And that's the beginning of the whole story.
The news of the discovery of the first planet beyond our solar system reverberated round the world. Marcy and Butler swung their telescopes onto 51 Peg and independently confirmed the discovery. There was indeed a planet racing around the star.
We were so shocked that we didn't believe it was a planet at first, and we had to go to the telescope ourselves to confirm it. And the reason it was a shock was that this planet goes around the star 51 Pegasi, taking only 4 days.
I wish I could say that I was so clever, that I had such great imagination that I would have envisioned such a thing. We were expecting that the planets that we were going to find were going to have orbital periods of like 10 years or 20 years, like Jupiter and Saturn. 4-day orbits, no, that was off scale. That was completely inconceivable.
Not only was the planet orbiting fast, but it was orbiting just 4 million miles away from the star. No one had ever dreamt that a planet could exist so terrifyingly close to the fiery surface of the star. In their search to find a distant world like our own, the planet hunters had found the universe to be far more frightening and hostile than they'd ever imagined. With the discovery of the first planet orbiting the star 51 Peg, they had stumbled across a world of violent extremes. The American team returned to their old data to see if they had missed other fast-orbiting planets.
Here we were realizing for the first time that there might be planets that took only a few weeks or months to go around their star, and it's like finding a gold vein in a mine. We now knew where to look for the planets. Some of them might be in fairly close. And we looked, and sure enough, we found dozens of them.
A disturbing trend began to emerge. Many of the stars in our galaxy have giant, super-hot planets in close, fast orbits. One planet, 170 times bigger than Earth, races round its star in just 3 days. The quickest ever found. Another is 1,100 times larger than Earth, but orbits 8 times closer. And the surface of the hottest planet ever found is scorched at more than 1,200 degrees Celsius. It was a mystery how such large planets could be orbiting so fast and so close. How did they fit into the astronomers' traditional theories of the way planetary systems are formed? on the west coast of America, one man who thought he had the answer was Professor Doug Lynn.
The general reaction at that time was that there's got to be a mistake in the data, in the interpretation of the data. This could not be due to a planet because it looks so different from our own solar system.
Orbiting close to our sun are 4 small rocky planets, including the Earth. Beyond them, hundreds of millions of miles out, lie the gas giants. Jupiter, larger than all the other planets put together, is made almost entirely of hydrogen and helium. And Saturn, 800 times the size of the Earth, is mostly hydrogen. Based on this pattern, the astronomers have built a theory of how planetary systems are born and how they evolve. They believe young protoplanets are created from a giant spinning disk of gas and dust that swirls around the nuclear fires of a newborn star. Over millions of years, the fine grains of dust cluster together. Their gravity grows and attracts more material until a planet is formed. The lighter elements, such as hydrogen and helium, are blown to the edge of the disk, where they collect to form giant gas planets. The heavier substances, silica and iron, remain close to the star, where they eventually form small rocky planets. This was a theory that couldn't explain the presence of a gas giant so close to a star like 51 Peg.
I feel that there's not enough time in the day for me to work on all these problems. The discoveries are coming in an incredible pace. And we need to, as a theorist, we need to come up with new theories, develop new theory to account for all of these observations. This is a theorist's heaven. In fact, it is the golden age of astronomy.
Lynn soon realized a radical idea was needed to explain the existence of the gas giants in close orbits. He used a computer to construct a new mathematical model of how large planets grow and evolve from a spinning disk of gas and dust.
I worked very quickly to develop a theory to account for how these planets may have formed at very far away from the star and then gradually migrate to the neighborhood of the star.
Lynn's breakthrough was to realize that a giant planet could be born far from its parent star and then spiral inwards, finishing in a tight circular orbit. But Lynn's theory dashed any hopes that stars like 51 Peg might also harbor small, rocky, Earth-like planets. If any of these young protoplanets had existed, they would have been bulldozed into oblivion as the gas giants spiraled in toward the star. Peg and its newly discovered planet lie an almost unimaginable distance from Earth. Today's fastest space probes would take 500,000 years to get there. But if thousands of years into the future, an interstellar spaceship on a scientific mission reached 51 Peg, what would it find? Physicist Andrew Collier Cameron thinks he knows the kinds of conditions we could expect to find. Far ahead of any interstellar probe, he's using spectral analysis of distant starlight to understand what these gas giants are made of.
Every once in a while in astronomy a new phenomenon is discovered which you can't actually see. It would be like on this world, and then you use science to flesh in the numbers, the temperatures, the pressures, the kinds of material that are likely to be present, and eventually you finish up with a complex picture of what the atmosphere of a planet might be like, even before you've seen it.
Collier Cameron is trying to confirm preliminary observations that some of these gas giants have atmospheres containing sodium and potassium, and the atmosphere of any planet so close to its star must be superheated.
They're incredibly hot because they're 20 times closer to their parent stars than the Earth is to the Sun. So you can imagine that these planets, being 20 times closer, are actually being spit roasted.
In this inferno, even solid metal would be vaporized.
Here on Earth, we think of most metals as being solids. However, you can imagine that if you heated the Earth up to, say, 1100 Celsius, some metals would melt and boil, and they would then become gases in the atmosphere. And this is the situation that we have. It's so hot that some of the metals exist in the atmosphere as gases.
With such extreme conditions, the planet orbiting 51 Peg would challenge any mission, even with the most advanced technology. On its scientific mission, the interstellar spaceship finally reaches its destination, the planet orbiting 51 Peg. The gravitational grip of the star is so great that one side of the planet permanently faces the searing heat with temperatures well over 1,000 degrees Celsius. The far side freezes in permanent darkness. The spaceship dispatches a probe down into the atmosphere. It enters a maelstrom of superheated, noxious gases, where winds top 1,000 miles an hour. The probe is bombarded by lethal radiation. Poisonous clouds of methane, sodium, and potassium envelop the probe. giant bolts of lightning up to 1,000 miles long strike all around it. The probe plummets down through a hailstorm of rock particles. Down here, nothing can survive.
Anybody like myself who as a kid grew up on a steady diet of science fiction, the very idea that within our lifetimes we're beginning to be able to study what the atmospheres of planets around other stars are made of is certainly an adventure that I wouldn't seriously have dreamed I'd be able to do.
Until 1995, the idea of finding other planets was pure science fiction. Now, astronomers have found more than 70 planets orbiting other stars. Some 10 times the size of Jupiter. Others with magnetic fields 1,000 times stronger than anything on Earth. And some are so close to their star, they are literally evaporating. But the astronomers were still no closer to answering the biggest question of all. Is there another planet like Earth?
For me, it will be the most exciting discovery of all. Because why are we doing this? Why should anybody care whether there are planets on other stars? Well, ultimately, we humans care about the Earth, and we would like to know whether there are other solar systems that harbor Earth-like planets.
The astronomers needed to find a solar system that resembled our own, where small, rocky planets had a chance of survival. In California, a colleague of Jeff Marcy and Paul Butler is planet hunter Deborah Fisher. Her driving ambition is to find a planetary system like our own. She is convinced that we're on the verge of discovering a planet where humans could survive.
Now we begin a new era, I think, of finding systems that are much more like our own. And I think that the first 70 planet discoveries that have been made over the last 5 years probably don't represent the planet discoveries that are going to be made in the next 5 years.
Fisher monitors her stars from the Lick Observatory, just south of San Francisco on Mount Hamilton.
When I go up and I see the telescope domes, the thing that always strikes me is that these are monuments to mankind's curiosity to try and find out who we are and what our place is in the universe.
She comes here to look for evidence of multiple planets orbiting a single star.
I always feel very lucky to be the first one sometimes to sit down and look at the data and see that there's a planet there and to have one more piece of the puzzle.
After years of searching, her dedication was about to pay off. One of the stars Fisher had been monitoring was Upsilon Andromedae. As she analyzed the faint starlight, Fisher's equipment registered that the star was wobbling, but in an unusual way. She calculated that there must be more than one planet out there, but even two planets couldn't fully explain the complex motion. The star was moving in a way no one had ever seen before. Deborah Fisher had discovered that the star Upsilon Andromedae was being pulled in different directions by the gravitational force of several planets. For the planet hunters, it was the breakthrough they had all been waiting for.
When we realized that there were 3 planets in the system and not 2, it was astonishing. My first fear was that, I was wrong. I'd done something wrong, and I would look foolish, when this news came out. And as I became more confident that in fact this was the correct description, the correct model for the system, it was very profoundly moving.
In 1998, after 2 more years of checking her observations, Deborah Fisher announced her discovery. But her hopes of finding a planetary system like our own had been shattered. There were indeed 3 planets, but they were all gas giants. This planetary system was as hostile as anything the astronomers had seen before. Like 51 Peg, Upsilon Andromedae had a close orbiting hot planet, but it also had 2 other gas giants that swung out through wild, eccentric orbits.
And that has some pretty amazing implications, because a planet in an eccentric orbit is going to spend most of the time far away from the star in sort of the cold reaches, and then it will dive quickly around the star where it's very hot.
Following Fisher's discovery, other eccentric planetary systems soon followed. But there was still no chance of finding an Earth-like planet. When a gas giant swings close to the parent star, its gravity would force any rocky planet out of the system. The astronomers knew that an Earth-like planet could only survive if the gas giants were like our own, in circular orbits hundreds of millions of miles out from their stars. It was a quest that would require them to watch their favorite stars for years on end.
Our fondest goal is to find planets in circular orbits with orbital periods of like 10 or 20 or 30 years, similar to Jupiter and Saturn in our own system. If we saw such planets in circular orbits, that would be a fabulous discovery, because it would be a signpost that this is the sort of solar system that might have other better planets.
The search was slow and frustrating. After more than 15 years of planet hunting, there was still no sign of a planetary system like our own. But the planet hunters never gave up hope. In the late summer of 2001, their luck was about to change. 3 years after finding their first planetary system, the planet hunters stood at the brink of another groundbreaking discovery. At the University of California at Berkeley, Deborah Fisher remained convinced that she could find a planetary system that could harbor an Earth-like planet. Near the familiar star pattern of the Big Dipper lies 47 Ursa Majoris, one of the stars that Fisher had been tracking for many years. She already had evidence that 2 planets orbited the star, but she had also discovered something far more promising. Both were following circular orbits, far from the star.
Now, for the first time, we have a star with 2 gas giant planets that are well outside of where Mars would be in our solar system that appear not to have migrated in. They're not in eccentric orbits, they're in fairly circular orbits.
Here was the perfect configuration. The 2 planets are very similar to our own gas giants Saturn and Jupiter. Perhaps here was a system of planets with a pattern like our own. Most important was the absence of gas giants close to the star.
From our detection technique, we have a big empty gap that sits between the star and the inner planet. So, is there something there that could be a terrestrial type planet?
For Fisher, 47 Ursa Majoris offered the most promising conditions she had found so far. For the first time in almost 2 decades, the planet hunters had discovered a place that could be hiding another Earth. If there is an Earth-sized planet orbiting 47 Ursa Majoris, how could the planet hunters detect its presence? Any wobble it would produce in the star would be too slight for astronomers to pick up with their current technology. At the Keck telescopes in Hawaii, scientists are now paving the way for the next era of planet hunting. Here, an ambitious plan is underway to combine the light of the 2 Kecks and create a virtual super telescope. If he can make this happen, optical engineer Mark Swain will give the planet hunters a telescope powerful enough to detect planets as small as Earth.
To find a smaller object, you need a bigger mirror. And you simply can't build an enormous mirror. And so if you hook 2 small mirrors or more together in the right way, you can simulate a much larger mirror so you can see a smaller object.
Swain has to make sure that light waves arriving a millionth of a second apart at the 2 telescopes can be recorded at exactly the same moment. Beneath the Keck domes lie a series of super clean tunnels. It's here that starlight from one telescope is delayed and combined with the light of the second telescope.
The light does travel very quickly. It can go around the world about 7 times a second. And so for the light that arrives first, we have to divert it. And we send it down a system of mirrors that actually run back and forth in a little railroad cart on a track. And that adds time to that light beam. So we control the position of this mirror to 1/10,000th the diameter of a human hair. And that adds 1/1,000,000th of a second of delay before we combine the light.
In March 2001, Swain managed to combine the light from the 2 Kecks for the very first time. He has created a telescope with a virtual mirror the size of a football field. It may be only a few years before this technology reveals to them their first small rocky planet. Even more ambitious ambitious planet hunting projects are planned for space. The first is scheduled for launch in 2006. The $300 million Kepler telescope will continuously monitor 100,000 stars, scanning for any brief dip in light when planets pass in front of them. During its 4-year vigil, Kepler should pick out even the tiniest star blink, indicating a planet as small as the Earth.
The detection of an Earth-like planet is going to be very difficult, very challenging, and there are technical hurdles to overcome. But I believe that in the next decade, we have a good chance of actually getting an image of an Earth-like planet orbiting a nearby star.
But what if the planet hunters do realize their dream and find an Earth-like planet orbiting a star? What would our spacefaring descendants find when they arrive there? In such a varied and extreme universe, even this long sought-after world may not be an identical twin to Earth. Any slight variation in its orbital position could make it too cold or too hot for humans. But other life forms may be more resilient. A new group of scientists, astrobiologists, have made the extraordinary discovery that primitive life forms could exist on even the most inhospitable rocky planets. Lynn Rothschild and her colleagues at NASA are conducting tests in the most extreme environments on Earth. They're trying to find out under what conditions life could take hold and survive on another planet.
When we look at a planet and we think of it as a hellish place, we have to always bear in mind that when life arose on Earth, it was a hellish place. The early Earth was in a period that we call the Hadean. It was hellish. It was a time where there was no oxygen in the atmosphere. Temperatures may have been radically different from today. It would be something out of science fiction.
Rothschild collects samples from these boiling, noxious pools at Yellowstone National Park in search of microorganisms, some of the most resilient life forms on Earth.
We're starting to think of life in terms of the whole planet. What does the climate shift of the planet mean? What does the tilt of the planet mean? How close it is to the sun, how far away, how the atmosphere might change. All these things are suddenly...
Her initial results are dramatic. Rothschild has discovered that life can flourish at temperatures 30 degrees above boiling point, with no oxygen, high salinity, and with extreme acidity. Life can exist in far more extreme conditions than we had ever thought possible.
30 years ago, we wouldn't have thought that organisms could live at temperatures of boiling water or at 0 pH, extremely acidic conditions. All of a sudden, the idea that life might live on a planet circling another sun suddenly becomes not so crazy. And it's possible in the next 20 or 30 years, we'll even be able to push this envelope of life out even further. We may be able to find organisms that can stand even more extreme conditions that we find them in today. And this will make it even more possible that we'll find organisms on extrasolar planets.
Rothschild's work suggests that when scientists eventually do find a rocky planet, whatever the surface conditions, we can expect to find primitive life at least. The discovery of new planets is a scientific milestone that will change our entire view of the universe. So far, we've only discovered worlds that are visions of hell. But out there may be new worlds that are more hospitable, more like our own. And maybe in the next millennium, we will build space arks, giant spaceships equipped to carry whole generations of humans as they set out to explore and colonize new planets across the galaxy.
One of my great dreams in life, and who knows, maybe it'll happen, is to fly in a spaceship with some newfangled propulsion system, taking us close to one of these extrasolar planets that we've discovered around a star.
These future spacefarers will be the ultimate pioneers.
The true nature of the planetary systems out there in the universe is yet to be discovered.
Our galaxy is filled with billions upon billions of stars, and beyond lie countless more galaxies. Who knows what the next generation of planet hunters will discover? We stand at the beginning of the greatest chapter in the history of human exploration.